Acquiring mesh surface data is a powerful way to use Magma to actually marry your particles to scene geometry. And I'm going to create a simple scene in which I'll have, again, a teapot sitting somewhere here, converted to particle volume, PRT volume, and I'll create a plane underneath. And let's say that I want to perform an operation like put all the particles down on the plane. In order to make it more interesting, I'm going to add a little bit of segmentation to this plane and add a noise modifier on top, so we get a little bit more interesting result. So that was normal and not noise. So we need the noise. Here it is. And I'll add a little bit of noise to this, possibly fractal noise. Okay, so let's take these particles and make them a darker color so we can see them better. And the other thing that I need to do, I think I changed the color of the teapot itself. I'm going to hide this original teapot and actually change the color of the particles. Now we have these blue particles. All we need is a Magma operator. And we'll say that the output will be actually the position. And the input that we're going to use here will be a object nearest point. I press N for nearest point. And it's already connected. The position will go out. All I need is an input geometry where I'm going to pick my plane and lookup point, which will be my position. If I update now, it will kind of look right, but it will be actually offset. And if I had my object shifted, it's actually moving in object space, and that's not good. What I actually need is to convert this transform to world space in order to go to the right place. And since I have a noise on top, the particles are finding the tips of this noise plane and gathering there. They don't go directly straight down, but finding the closest point that is the highest one. If I disable the noise, you're actually going to see the correct projection down, because the z-axis is the closest way from all the particles to the plane. Here where it is, and then it goes down. But what happens if I start moving this object to the side? You see that all of the particles will gather at the edge, because that's the closest point to the surface, and that might not be what you want. What you want is probably project a ray down, hit the surface, and if it has a valid hit, stay there, otherwise just stay where you were. So I'm going to switch this nearest point to an actual intersect ray, and intersect ray needs a third input, which will be I'll create it by default 0, 0, -1 array going down. And now if I start moving this object, it won't do exactly what I described, but it will be close. If I move it to the side, the particles disappear, but they actually gather at the origin, because they are getting a position of 0, 0, 0 when the hit was invalid. I can work around this easily because I have an isValid test here. I can go and say I'll create a logical operator and say if this is valid, I will have a switch which says when it's valid, take this world position and pipe it out. So I'll output the result here, and otherwise output me the original position of the particle, and here's what we get. If I start moving out, the particles start appearing back. And in fact, I can move the plane and review the teapot. When the plane comes, the particles go down to the plane, and when the particle leaves, they build the teapot again. This is much better, and we can go even further, and we can add another rule which says we'll take the distance to the plane and measure it and see if it's below or above a certain threshold. So I can go here and say logic, if it's less than certain amount of units, let's say 50 units, then it's cool, and we're going to do the switch. So we'll need in this logical control wire here to add, let's see, this wire. I'm going to do logical AND, and I'll wire this test here. And now we say if the particles are 50 units or less to the plane, they will project down and the rest won't. So you see, if I start moving the plane up, all of them project. If I start moving it down, less and less particles have that distance of 50 units. And I can, of course, go and expose. Let me reorder this in a better way. I can expose this distance here and say 100 units now. 100 units is good. I can move my object up, and when it's above 100 units, it stops projecting. When it's below 100 units, it projects, and it still does all the tricks that we did before with moving and revealing. All right. So this was the nearest point to surface test and the intersection with surface that we just did. And one thing that you'll do a lot, I guess, is actually stealing UV coordinates from the nearest point or from intersect ray. Let's assume that this is what we want to do. We want to actually have some texture on this plane. I'm going to assign a new material to the plane, and I'll add some texture, a bitmap. And this bitmap I'll take from my backgrounds here, and I'll use, for example, this texture. In order to make it a little bit more visible, let's show it in the viewport. I will go here to the top viewport, switch it to shaded view, and actually I'll set it to consistent colors so I can see much better the original colors. Let's switch to the full view. And if I select this object and assign exactly the same material and update, my teapot is actually, the particles are stealing the UVs from the original teapot. So it's shaded like the teapot would be. And what I want to do is actually get the UV coordinates from the plane underneath. So now that I have the intersect ray, all I need is add another face query. And the face query operator, I don't want it actually introduced there into the position connection. I'll keep the position connection. And I'll use this face query that was created automatically by pressing that button to steal the UV coordinates. So I go down to the list of all possible channels, find the texture coords channel, add it to the list, and that's what I will be outputting as a texture coord for my particle system. Let's connect the outputs, output to the input, and at this point, my particles are actually shaded just like the plane. I'm going to go and increase the number of particles so I can see them a little bit better, and to start moving that particle system around, and now it's stealing the UV coordinates. If I move to the side, they turn blue because they're actually getting UV coordinates of 0, 0, and that produces the corner blue color. But once inside the plane, they actually shade exactly the same. And I should probably move that a little bit down, so actually up, to get more particles. You see that all the particles along the vertical z-axis are getting the same color, and when I'm looking from the top view, they're completely invisible. This so-called predator effect, they're merging with the background. I wanted just to mention that creating the face query requires the same geometry input. Then we get the index of this mesh that was hit, because you can have multiple objects here, and the one that actually was the first hit will be output, then the face index of what was hit, and the barycentric coordinates. And using the add face query button actually automatically connected all of these inputs, so it's a very fast way to get test and figure out. And the face query is what you should be doing using when a channel that you need is not on the list of the intersect ray. It gives you access to normals, for example, but it doesn't give you access to mapping coordinates. So in that case, you just connect face query and get pretty much all the channels available in a mesh available there. So let's look at the next thing. This was actually the predator effect that we looked before. Testing inside and outside, we have a dedicated operator for this. And in order to show it, I'm going to create a few objects, actually 2 objects. I'll create a teapot converted to a PRT volume, and I'll create a torus which intersects it in some point. In fact, I'm going to, once again, hide the original teapot so it doesn't cast shadows there, and to switch this to wireframe mode so I can see what's happening inside. So now this PRT volume, I'll add a couple more particles in the viewport so I can see better, and I'll add a magma modifier on top and just use a in and out test to change, for example, the color or let's say, delete the particle. So I'll set the selection again, and I'll add a Kryktor delete modifier on top of the stack to delete those particles. And now all I need is object, and you'll see that we have an in volume. So you press OV, in volume. We connect this to the output, and this is a Boolean, so we again convert it to float, so the value will be 0 when it's false and 1 when it's true, and we need just a geometry input and a lookup position in world space. So I just drag the wires and it creates them. Now I can pick a scene object, in this case the torus, and let's see now if it updates. Yes, it does, and if I move my torus or my teapot, I'm eating away the particles because I'm selecting them, and then the delete is deleting them. If I want to turn this around, I can go and either subtract from 1 here to invert, or I can take the Boolean operator here and insert an LN, which is not, logical not, and that now deletes all the particles outside and keeps the ones inside. You can do the same by actually using, instead of in volume, which tends to be slightly slower because it performs more checks and it's more thorough, especially with concave objects and semi-open objects, like if the test volume was a teapot, it's better to use than in volume. But theoretically, you can also use a nearest point or intersect ray to shoot a ray in some direction and see if you're seeing the geometry from the inside to outside, or use a nearest point. And instead of using the position here, what I need is the distance. And I'm going to check this logical operator here will be switched to logic and less. And it says if it's less than 0, then it's true. And if it's greater than 0, I'll switch this to greater and watch this, it inverts it. Basically, the distance is actually a signed distance value, and signed distance means that it will be negative when a particle sees the geometry from the inside. That means it finds the closest point to be on the inside of a face. And when it's on the side of the normal, on the outside of the geometry, then the sign will be positive. And just checking for the sign with a greater or less operator gives you pretty much the same result for deleting.